If you were to look up at the approaching night sky on the surface of Mars, you might be surprised to learn that instead of the splendid reds and oranges of an Earth sunset, you would instead be greeted with Mars's ruddy orange sky fading into a deep pale blue as the small white disk of the sun faded below the horizon. Why are sunsets on Mars blue? To answer this question, we'll first need to jump millions of miles all the way back to Earth and figure out why the sky on Earth is blue to begin with. For the sky to have any color at all, we first need a source of light, in this case the sun. While the sun appears yellow in the sky, if you were to see it from space, the light it produces is actually white, meaning it's made up of all the visible colors. An easy way to prove this is with a prism, where the white light of the sun can be broken up into the rainbow of its component colors, from violet to red. When this white light hits our atmosphere, it gets scattered in a phenomenon called Rayleigh scattering, due to the light interacting with the small gas molecules in our atmosphere. This type of scattering sends the incoming light in all directions, and while the scattering affects all colors, it doesn't do so equally. The colors which are closest in size to the molecules of gas in our atmosphere, the smallest wavelengths, are scattered the most, blue and violet. But if violet is the most easily scattered, why isn't the sky colored violet? Well, it is. We just don't see it that way. How we see color is greatly affected by how our eyes work. Our eyes perceive colors by activating 3 types of cells in our retina called cones. One which detects red, one which detects blue, and one which detects green. While we only have 3 types of specialized cells to detect colors, these cells are sensitive over a wide range of neighboring colors. While the blue cone can detect blue, other colors can be observed by stimulating more than one of the cones. For example, we see yellow when both the red and green cones are activated in the eye. Our eyes can also see colors outside of the rainbow entirely, such as magenta, a color made up of both red and blue light. When both the red and blue cones are stimulated, our brain interprets the color as magenta, even though it's a mixture of 2 separate colors. When we look at the violet-blue light scattered in the sky, our eyes see it as a light blue color because our blue cones are less sensitive to the color violet, and the red and green cones are stimulated a little bit as well, lightening the hue of the color to the sky blue we perceive. Sunsets on Earth are caused by the sun getting lower and lower in the sky. When this happens, its light passes through more and more of the atmosphere, scattering the blue light of its spectrum away until the sun's light becomes yellow and then red. On Mars, this all looks very different. Its atmosphere is about 1% as thick as Earth's, so Rayleigh scattering, which depends on the small molecules in Earth's atmosphere, is less important. The fine particles of red dust which get blown up into the Martian sky lead to a different type of scattering called Mie scattering. This scattering is the same type of effect you occasionally see on Earth from the particles in a forest fire. Most recently seen when in 2020, San Francisco was bathed in an eerie orange light. Back on Mars, the large particles scatter the red light outward, causing its red sky, but scatter the blue light more prominently in the direction of the sun's light, causing the large halo of blue around the setting Martian sun as it encounters a thicker and thicker layer of dust particles, creating a sunset completely alien to our own, but no less beautiful.